Section, we're going to be looking more at polynomial functions, and in particular, we're going to dive into how to find zeros of polynomials and how to identify multiplicity of those zeros. Zeros, what we are referring to is what are the solutions to a polynomial function when that polynomial equation is actually set equal to 0. So whatever the variable is in that function, we would set it equal to 0 and solve for that variable to determine what the value of that function or what the value of that variable should be that makes the function 0. Zeros are also known as roots, or we call those x-intercepts. So in other words, that's just where the graph would cross the x-axis. So wherever, if we were looking at the function on a graph, wherever the graph or the line of that function crosses the x-axis, we would say that's a 0 or a root or an x-intercept. One thing to keep in mind is if a polynomial can be written in a factor form, so if possible, if we can factor it, then we can easily identify the zeros of that polynomial. Now, let's suppose we want to identify the multiplicities of zeros. So when we speak of multiplicities, we just mean when is the number of times or how many times does a factor of a polynomial occur or repeats, in such a way that if we have a factor in the form of x minus r to the k, and if we would set that equal to 0 and solve for r, then we would say r is the 0 or the x-intercept that we like to refer to as, and then we would like to say that k represents the multiplicity. So depending on the value of k, that lets us know how many times this particular factor would occur. So for instance, if k is equal to 1, then that just means this factor or that 0 occurs once. If k is equal to 2, then that means that this 0 would occur twice, and so on and so forth. So then we look and see, well, if r being that 0, if it has a multiplicity that is even, then that tells us that the graph is going to touch and turn around on the x-axis. So again, if k is even, if that multiplicity is an even number, then the graph is going to touch and turn around. However, if r, being a 0, has an odd multiplicity, then that's going to let us know that on the graph, it's going to cross the x-axis at that 0. So again, if your multiplicity is an odd number, then we know that the graph will cross at that 0 on the x-axis. So here we have an example of a polynomial function. It's already written in factored form. And we also have the graph of that polynomial function here. And so what we want to do is see if we can first identify the zeros of this polynomial function, and then we'll go further into determine the multiplicity of the zeros. So first, if we look at the graph, we can easily see that, remember, we refer to zeros as when the graph crosses the x-axis. So we can see exactly here at -3, we can see the graph crossing -3 here. We can also see here at -1, the graph is crossing there. And then we can also see here at +2, it may not necessarily be crossing, but it is touching and then kind of turning around at 2, right? So we would say those are the 3 places in which the zeros occur. Again, if we didn't have the graph and we just wanted to look at the factor form to determine those zeros, then we would just simply set each factor of this polynomial equal to 0. And so of course, if we look at this first one, set the x plus 3 equal to 0 and solve for x, we would get x is -3. So it makes sense that something is happening here on the x-axis at -3. With the second factor here, set that equal to 0 and solve for x, we would get x is 2. So it makes sense that something is happening here at +2. And then set this third factor, x plus 1 equal to 0, solve for x, we would get -1. So it makes sense that something is happening here at -1 on the x-axis. So that would be the zeros of this polynomial function. Then we want to see if we can determine the multiplicity of the zeros. Well, let's first look at this first factor, this x plus 3. So again, we set it equal to 0, solve for x, we get x is -3. Well, let's see if we can determine the degree of just this factor alone. Well, since there's nothing written here as the exponent, remember the degree is the same thing as saying the power or the exponent. Since there's nothing written there, it's an understood degree of 1. And so therefore, since it has a degree of 1, that's going to tell us something about the value of our k, which we refer to that as our multiplicity. So therefore, we say it has a degree of 1. Since 1 is an odd number, then that means it's going to cross the x-axis at that 0 of -3. And so therefore, since it has a degree of 1, that's the same thing as saying it has a multiplicity of 1. Now let's take a look at our second factor, the x minus 2. Again, we would set that equal to 0 and solve for x to get the 0 to be equal to 2. Now, if we identify the degree, we will see that the degree of this factor is 2. So since the degree is 2, an even number, then that's going to tell us that the graph is going to touch and turn at that 0. So again, even degree, even number, meaning it's going to touch and turn on the x-axis at that 0. So we can see here in the graph it indeed does touch and turn at 2. And so therefore, since our degree is 2 for this particular factor, that means it also has a multiplicity of 2. And now let's look at that last factor, x plus 1. Again, set that equal to 0. We would get x is -2, so we know we have a 0 there. Now, if we take a look at the degree of that factor, we see that that degree is of degree 3. And since that is a odd number, then we know that it should cross the x-axis at that 0. And we can see here it does cross there at -1. And so now, since we know it crosses there at -1, it has an odd degree 3. And since the degree is 3, then we know the multiplicity is also 3. So therefore, we have just identified the degree and the multiplicity of each 0. Now we want to see if we can take a look at this last example here. So we want to use this graph to identify the zeros and the multiplicities of each 0 of this polynomial function. Now we're given this information that this polynomial function, it is a function of degree 9. So whatever the function is, however it looks, we know that the highest power of that function is 9. So that's going to help us when we get ready to determine the multiplicities of each of those zeros. So let's first see if we can identify the zeros. So again, we know that zeros are where the graph crosses the x-axis or maybe kind of bump up and touch a turn at the x-axis. So we can see here at this first place here on the x-axis, looks like it's at -5. Looks like it's crossing there, so that's going to be a 0 there for this polynomial function. Now we just need to determine its multiplicity. Well, we do know, looks like it is crossing the x-axis at -5, so it looks like the multiplicity should be an odd number. Well, if we know something about graphs, we know that if it was a linear function, it would have a nice straight line going across the x-axis there. But here we can see it's kind of not exactly going straight across, but kind of turning a little bit as it goes across the -5 there on the x-axis. So we should know just by looking at different types of polynomial functions, this makes the shape of an x cubed type of function. So the highest degree of an x cubed would just be 3. So we're going to say that this one has a multiplicity of 3. Now let's take a look at another place on the graph where it looks like something is happening at the x-axis. So it looks like here at -1, look like it may be touching and turning there at -1. So we're going to say there's another 0. Well, if we know something again about the shapes of graphs, we know this looks like a nice quadratic formula here because of that U shape. So we know that the highest degree of a quadratic form is just going to be x squared. So therefore this 0 is going to have a multiplicity of 2. And then finally, it looks like we have something going on here along the x-axis. It looks like something is happening here when x is 3. So that's going to be our third 0. So now, since we have a 0 there at 3, you can see it's touching and turning around there at 3 on the x-axis. So now we just need to determine the multiplicity of that 0. Well, since it is touching and turning, we know that the multiplicity has to be an even number. Then we're given this information up here that this polynomial is a function of degree 9. So that means when we add up all of the multiplicities, remember the multiplicities are the same thing as the degree of each of those factors in the polynomial. So if we add up all of these multiplicities, it should add up to be equal to 9. So therefore, here we have 3 and 2, so we already have 5. So therefore, this multiplicity for this 0 should be a multiplicity 4. All right, and it makes sense that it's 4 because it's an even number, and we can tell indeed there at the 0, 3, it does touch and turn at 3. So now we have identified all of the zeros of this polynomial function, and then we have identified the multiplicities at each of those zeros.